To lesson 2, congruent parts, part 2, following up on obviously part 1. Now we talked about corresponding parts, and those are the parts that match between two different shapes. So if I look at these two shapes, I can tell which parts are corresponding, which parts match. So task 1, it says each pair of figures is congruent. So they're telling us right away that these two shapes are the same. If we move them around and flip them and turn them into, we can make them match up to each other. They'll cover each other perfectly. We have to decide whether or not each congruent statement is true or false. Now here's a congruent statement right here. It says triangle ABC is congruent to triangle FED. Okay, so if I look at this, the easiest thing for me to do is I find the pointiest part. Okay, so there C is the pointiest spot on this triangle. Now if I look for the pointiest part on this triangle, it's going to be D. And so I notice that C is in the third position here, A, B, C. It's in the third position. And here D is also in the third position. So those two are the ones that are going to go together. So far, so good. Okay. Now if I look at, let's say, the angle here at point B, that's a very open, obtuse angle. It's a very wide angle here. Okay. And over here on this one, the angle at point E is very, very wide. And that one is the obtuse angle. And I notice that B is in the second position and E is also in the second position. So that would make sense that they would match. And of course, A is the one that's left over there, and F is the one that's left over there. And those are in the first position. So those all match up. So here, this statement seems fine, right? If I were going to move ABC onto FED, I could slide this over and rotate it until E and D and B and C matched up, and then I could reflect it across there and it should match up. A would land on F, A would land on F, B would land on E, right? And C would land on D. C would land on D. So that's how we do this. We're just matching up the points and how they are in order of the statement. Okay? So this one's true. All right, great. Okay, so now we have this weird shape here, okay, this polygon, right? It's a 1, 2, 3, 4 sides, so it's a quadrilateral, 4 sides, quad meaning 4, and lateral meaning sides. So, right, there's our sides, and there's our 4, okay? So here we go. Okay, PZJM, so that's this one, PZJM is congruent to LYXB. So we have to determine whether or not that's a true or a false statement. Now, if I look at, let's see, what's a distinctive point here that I can easily identify? Well, this point P in the middle is obviously matching up with point B. So where is point P in our first description of this first polygon? Well, it's the very first letter, right? So that means that B should be the first letter here. And it's not. It's the last one. So they're saying that the P here corresponds or is supposed to match up to the first letter here, L, which is this one. That doesn't make any sense. That doesn't match up, right? And then Z, which is over here, would match up with Y. Well, that makes sense to me. And then X is down here, which is J, and then M would be up here, would be L. So there's definitely some mix-up in this letters. It's not like alphabet soup. You can't just throw the letters around in whatever order. So this one is definitely false, right? The way they've described this does not match with this one. The two shapes may be congruent, but this statement is wrong. It should be P would be B, so this first letter here would be B, and then Z is Y, so it would be BY, and then J, which would be X, so it would be BYX, and then L would come last because M is last, right? So this statement is false, okay? All right, next one up. Okay, so we're told that these two triangles are congruent. The question is this statement right? Okay, so let's see here. J is right here, and then K is the really pointy one. So it's easiest for me is like identify something that's obvious and sticks out, right? It's like K, that's where the super pointy end is, and L looks like it's a right angle, right? So, and then this is the other angle to me. Okay, so let's see here. K is the super pointy part, so that should be, let's see, which part would that be? That would be Q over here. Okay, so K has to match up with Q, and L, which is like a L-shaped right angle, looks like a right angle, but that's just like my opinion, man. That looks like R, because R is kind of a right angle shape too. So L should match up with R. So let's see what we've got here. So K is in the second spot, and that should be Q. So Q should be in the second. Okay, they screwed it up here, right? Q should be in the second spot. If K is in the second spot, Q should be in the second spot. So this is definitely wrong. Okay, and let's see what they do with L. L is in the last spot, and R is in the second spot. It should have been in the last spot because it's in the third spot here. So what should this statement be? If it's JKL, so J would be S. So it should be J would be S, and then K would be Q. So it should be S, Q, R instead of QRS. So, okay. So this statement is also false. Okay, this is also a false statement. Okay, this one didn't work. All right, looking at this one. A, B, C, D, E. Okay, great. Alphabetical order. Same thing here. P, Q, R, S, T. All right, okay, whatever. All right, I can look at this and I can say that A, B, C, D, E, these go around in this direction alphabetically, right? Okay. The other thing I can say is that these look like they are all the same length and they have the same angle. Every angle all the way around is the same, okay? And same one on this side, right? On this pentagon, right? So as I look at this, I noticed with these other ones, like each side was definitely different and the angles were definitely different. I think that here they're trying to say that all of the angles are definitely going to be the same. There's not like this is just, I'm going to try and trick them and make it just a tiny bit shorter or longer or something like that. I think they're generally saying that all of these things are the same length all the way around. So we should be able to just slide this thing over and make it match, okay? So let's see here. They're saying that A matches up with P. Okay, so if I put A over here where P is, okay, let's see, and I keep going around this way, be A, B, right, and then P, Q, Q. I'm still going around this way, which is counterclockwise, right, because clocks go the other way, right? So P, Q, R, S, T, and A, B, C, D, E. So this seems to make sense, right? Because if A goes first, and then B comes next, and then C, right? It would be P, then Q, then R, then S, then T. So this makes sense. They didn't put them out of order, right? They didn't jump around. They didn't go P, Q, R, S, T, like they didn't cross the shape in any weird way. So everything seems to be fine with this one, okay? So that one's true. Okay, here are 3 triangles. Alrighty. Okay, so let's see. What am I given here? What does this diagram tell me? Well, this diagram tells me that, let's see, I've got 3 triangles. I'm seeing some measurements of some angles here, 46.6, and this is 46.6 also, and so is this. Okay, great. And I've got some numbers here on the outside of the triangle. So those are referring to how long the edges are. So from P to Q is 5.9. We don't know if that's inches or feet or miles. Maybe this is a map. Who knows? Okay. And then over here we have 5.9, and we also have 4.3. And it looks like they all have. So if you start with the angle here, and we kind of go around, we go from 46.6 as an angle, and then the side that's next to that is 5.9, and then the next side after that is 4.3. So let's see if I can do that each time. So here is an angle. That's 46.6. I go along that edge, and I've got 5.9, and then the next side over as I go around is 4.3. Same thing over here. I start off with my angle, 46.6, and then I cruise along, and I've got my side that's 5.9, and then the 4.3 side. Okay, so it looks like they're all sort of set up in the same way. Okay, so what is it saying? Okay, triangle PQR, okay, PQR, that's this one down here, is congruent to which triangle? Explain your reasoning. Okay, well, how do we do this? I mean, we've always done our checking for congruence by matching things up and making them like lie on top of each other and just sort of like match up. So let's just try this one and this one, and we'll see if that works. So, okay, first things first, I know that this angle right here is 46.6, and this angle right here is 46.6, so these corners have to go together. So I'm going to translate first. Okay, so I'm going to go up here to my transformations menu. I'm going to translate by vector. I'm going to select inside of this triangle here so that I've got the whole triangle. Notice how it highlights. And then I'm going to say that I want it to go from P over to A. Okay, so there, we've done that. Okay, I'm going to move this a little bit so that I can keep these two on here. All right, there we go. Okay, now, as I'm looking at this, I'm like, I think that if I move this Q prime up here to where C is, that might allow me to sort of reflect it down and then match it up. Okay, so that's what I'm going to try and do. In order to do that, I'm going to have to rotate this. I'm going to have to rotate this triangle right here, this triangle. I'm going to rotate this triangle. I'm going to rotate around point P. Oh, wait, you know what? I didn't, I know I'm going to rotate counterclockwise because we're going over this way, right? But I don't know what the measurement of the angle is. So what can I do? Okay, well, let's see here. So I want this Q prime to land up on C. So basically this angle right here is what I'm looking at, right? This angle right here, Q prime, A, C. That's the angle that I want to know. So this tool right here is the angle measure tool. Okay, so I'm going to do that. Q prime, and then A, and then see how it's giving me that thing and I can measure, right? But I want to go over here to the C because that's the angle that I want. Okay, so it gave me a number here. Let me move it so I can see what the heck that number is. Okay, so this is the 46.6. So it looks like 24.6 is that angle that I want to rotate by. Okay, 24.6. See if we can remember that. Okay, so we're going to rotate around point. So this triangle here is the one I'm going to do. So I'm going to click right there. So I'm selecting the whole triangle, and I'm going to do around this point A, and I'm doing, what was that again? 24.6 degrees, and we're going counterclockwise because we're going that way over that way. Okay, so boom. Okay, great. So we got this edge to match up. Okay, we got that edge to match up, which is what we wanted. Now, I don't want to see this other triangle because there's a lot of stuff going on here. So I'm going to go over here to the Show and Hide Object menu, and I'm going to hide this point right here, Q prime, and I'm going to hide this point right here. And then when I go back to the Move menu, that should make the triangle disappear. Nope. Darn. Okay, so let's click on this triangle too. Nope, that's not what I wanted to do. We'll do this triangle right here. Yeah, okay, there we go. Now I'm gonna, there we go. Oh, it didn't do it. Okay, wait, let's go back. How come it didn't do that for me? Did it before? Okay, let's try that. Okay, there we go. Okay, so far so good. And again, I'm going to hide these points right here. All right, there we go. There we go. Okay, I got it all hidden. Okay, so now, since I have this edge here, I'm going to reflect across that. Okay, so we're going to reflect about line. Okay, we're going to select this triangle right here. And then this is the edge I want to use. So I'm going to click right along that edge and get it to reflect. Oh, it didn't match up. There's this extra sticking out here. So it doesn't match up. So these two don't match. They don't. They just don't match. They're not the same. Which is weird because we had an angle and we had a side and we had a side that were all the same. So whatever. Okay, well it didn't match. Okay, so it's got to be this one. It's got to be over here. It's got to be this one. All right, so let's see here. Triangle PQR is congruent with which triangle? Explain reasoning. Okay, let's see. Well, P has to match up with M, and R looks like it's kind of almost a right angle, and L looks like it's almost a right angle. So if I was going to do, whoops, it says PQR, so I'm going P, then Q, then R. So I'm going to go M, then N, and then L last. So I'm going to say PQR is congruent to triangle M and L because, well, why? Well, because we tried the other one and it didn't work. Okay. All right. I think all that typing is really loud. I'm gonna not type stuff. But anyway, okay. I shouldn't say it didn't work. I should say it didn't match up. All of the points didn't, and all of the corners didn't match up. Okay. On triangle AEC, right? ACE. Okay, great. Okay, so now so we're going to do, it says show a sequence of rigid transformations that takes PQR to that triangle. Okay, so it's going to go up to this one then. Okay, draw each step of the transformation. Okay, well, we just have to do it. Okay, so translate first, then rotate, and then if we need to, we reflect. Okay, so first off, we're going to translate. So translate by vector. And I know that this P has to land on that M. So I'm going to select the triangle. That highlights all the edges, and then I'm going to go from P over to M. Boom. Okay, so it's off the screen. I'm just going to move it a little bit so that we can see what we're doing here. Maybe I'll zoom out a little bit. There we go. Okay. No, oops, too much. There we go. Okay, so now, actually, we don't even need this whole triangle over here. There we go. I don't need this thing either. There we go. Okay, great. So, so now, all right. So once we've got that, we translated this. Notice that we just slid it over. Okay, we just slid it over. Didn't change the orientation, didn't rotate it at all. So now what we're going to do is we're going to rotate this, and I'm thinking that this R is going to just go up to that L. And again, we're going in a counterclockwise direction because clocks go the other way from what I'm doing right now. Okay, so we have to measure this angle to know what that is. So I'm going to use the angle measure tool. And I'm going to click on the R prime, and then the M, and then the L, and we're going to get a number. Okay, 26.15. All right, everybody remember that so that I can remember it or whatever, or ask you. But that's not going to work because this is just a video. All right, so 26.15, that's how much we're going to rotate this so that it lands up there. Okay. Okay, here we go. Rotate around point. Select this triangle. We're going to select point M. And what was it, 26.15? I think it was 26.15. I hope it was. Yes, it was. Good. All right. So we got that to match up, which is great. Okay, we got that to match up. All right, now we have to reflect it, and we're going to reflect it across this line right here. Let me put a line in there just so we can see it. Right? This is the line we're going to use for reflection. Okay? So we're going to reflect about line, selecting this triangle here, okay, just by clicking in there. And then we're choosing this right here as our line of reflection. Boom, and it matches perfectly, right? You can even see the numbers here matched up, okay? The numbers matched up. And we can tell what letters match up so that we can say it in the right order. So it would be PQR, right? So PQR. P matches with M. Q matches with N, right? Because the N and the Q are together. And then L and R are together. Okay, so explain why there can't be a rigid transformation to the other triangle. Well, the other one is not, it's not the same shape, right? It's just not the same shape. It's close to the same size, I guess, but it's not the same shape. It's not the same triangle. So unless you stretch it, you're not going to make it work, okay? So you would have to do a non-rigid transformation. You would have to flex it somehow in order to make it fit. And so they're not the same shape. The answer to this question is, it's because they are not the same shape, okay? Okay, so now we're going to look down here. All right, triangle ABC is a rotation of triangle CDB around point E by 180 degrees. Okay, let's break this down. So if I'm looking at this, triangle ABC is a rotation of triangle CDB. ABC, there is no triangle ABC. Okay, oh, you know what? This is supposed to be a D right there. It's supposed to be ABD. ABD is a rotation of triangle CDB, right? CDB, we take that, we spin it around this point here, point E, right? Spin it 180 degrees, and it'll land where this triangle is. That letter right there is supposed to be a D. Okay, great. So now, all right, okay, great. Now we know what we're going to be talking about for the next couple of problems here. Task 10. Is angle ADB congruent to angle CDB? Okay, wait a minute. ADB, ADB, ADB. Okay, so they're looking at this angle right here. All right, so ADB, ADB, right? So this angle right here, is this angle congruent to angle CDB? All right, let me switch with my colors here. I'm going to go blue. Okay, there we go. CDB, CDB. So this angle right here, they're saying, are these two angles congruent? If I took this triangle over here, if I took this triangle here, which maybe I'm wondering if I can color these in. If I go to highlighter. And go to here like this, right? All right, so this triangle here, if I took this triangle here and I rotated it around 180 degrees around point E, right there, right? Where would the various points land? Well, That's a tough one. Well, obviously, if I'm rotating this, D's going to spin around, and it's going to, well, C is going to end up where A is. D is going to end up rotating around. It's going to be where B is, and B will end up down here where D is. So if I think about it, this angle at D is actually this angle up here, isn't it? Let me look at that. Actually, let me draw some lines here. So if I think about this, remember that if you have a line and you rotate it 180 degrees, if you rotate it by 180 degrees, if you pick the center of that line or somewhere on that line and you rotate it 180 degrees, it'll land right back on itself. But if you pick some other point that's not on the line, this thing is going to rotate around and it's going to end up over here, and it's going to be a parallel line, right? It's going to end up over here. I can kind of sketch this out a little bit. There we go. It's going to end up over here, right? And these two lines are going to be parallel, okay? And then the same thing would be true of this edge here, right? CD, right? We rotate this one around 180 degrees, and it's going to land up top. Missed. Close, though. There we go. Okay. Now, if I'm looking at this blue angle here, do you guys remember? You guys remember what we did, right, when we were talking about all those angles? You see the Z shape? Let me make this really. I'll go back here. I'll go this way. Right? Right, the Z shape. Right? Here's our Z. And this is alternate interior angles. Right? This angle here and this angle here are the same. Right? This one and this one match. There's my Z. Okay? And if I go back, right? And then I can make the other Z going the other way. Right? I can go this way. I don't know, this might be a backwards Z. We'll see. Go there, and then this way, and then this way. Yeah, I think that's a backwards Z, isn't it? Yeah. Anyway, so that this angle here has to match with this angle here, okay? So, whoops, let me get the pen, go here. This angle, right? The red angles are going to match up, and the blue angles are going to match up, okay? So let's look here. It says, is angle ADB congruent to CDB? No, they're not, because they are not corresponding angles. This triangle, when you flip it over, when you rotate it around, I shouldn't say flip, sorry. When you rotate it around 180 degrees, this angle right here, oops, didn't mean to make it red. Let's do that in blue, right? This angle right here is going to end up here. Okay? This corner is going to rotate around. It's going to end up there. This corner is going to rotate, oh, excuse me, this corner is going to rotate around and end up down there. Okay? So, they are not corresponding angles. If that triangle rotates around 180 degrees, these two angles are not corresponding angles, so they are not going to be congruent. All right. If not, which angle is ADB congruent to? Well, we just figured that out. ADB is the red angle. AD, here, let me move this. There we go. ADB, right, the red angle, is congruent to what angle? Well, we looked at it. It'd be this one, CBD. right? This angle here, okay? So that one's that one, okay? Okay, here we go. This says polygon HIJKL. HIJKL, is that alphabetical? HIJKL, yep. All right, HIJKL is a reflection and translation of polygon GFONM. Okay, so that means that this one down here is the original. I'm going to highlight that one as our original. So this one down here is our original, and then the other one is just a, what they say, a reflection and translation of the other one. Okay, so that's the information that we're given. Okay, so now let's see what we end up with here. Okay, we are looking at this. It says, is segment KJ congruent to segment NM? KJ, NM. Where's KJ? All right, so KJ is right here. KJ is right here. All right. So the question is this congruent to, what did it say? NM. Okay, NM. All right, let's make that one a different color down here. NM. Okay, so we're asking if these two are the same, if they are congruent. Well, are they corresponding parts? Let's see here. So if this is my original, wait, which one's the original? Yeah, if this is my original and I slide it and flip it, or flip it and slide it, right? If I it says reflection and translation. So if I flip this up across this line and then slide it down, where's this going to end up? Are these corresponding parts? Excuse me. It looks like JK. If these were two mountain ranges, right? These are two mountains. Then JK is on the inside between the two mountains. And then here, NM, that's on the outside of the two mountains. So they're not the same. They're not the same. They're just not. Okay? So they're not corresponding parts. So no, right? We can't say that they're the same. They might happen to be the same length, but they're not corresponding, so they're not necessarily congruent. We can't say that they are. So we have to assume that they're different. Okay? If not, which segment is NM congruent to? Okay, so which one is NM congruent to? Well, if I flip this up and then slide it down, where does NM end up? Well, N is this peak right here. So if I flip it up, it's going to end up here, and then I slide it down, it's going to be K. So N is going to be K, and M is going to be L. So KL. So if they did NM, what did they do? NM. NM is going to be KL. Okay? All right. Great. Awesome. So this one is this one. Oops. Well, that was terrible. Okay. The blue ones match, guys. The blue ones match. All right. So now, all right, quadrilateral PQRS is a rotation of polygon VZYW. Okay. They did not give us a diagram here. You know what? If they don't give you a diagram, it means that it has to work with any shape, any quadrilateral that you have, right? So not necessarily a special quadrilateral. So any shape that's a quadrilateral, this should work for. So do I have a way that I can draw on this? I don't think I do. Is there a workspace? Okay, we're going to use a little corner here to do a little diagram here. So I've got PQRS. Okay, so we're just going to draw a random polygon here, quadrilateral. So I'm going to go like this, and then I'm going to go like this, and then I'm going to go like this. And then I'm going to go like this. Okay. Okay, great. All right. So, and what I'll do is I'll put in P. Q. R. And that one's kind of, there we go. PQR. Oops. Let's put that right there. R, and then, oops, need this. And we'll put S here. There we go. Okay, PQRS. Okay, so we have our shape. Okay, and I know some of these pieces don't quite match, but there we go. Okay, PQRS congruent. Is it okay? It's a rotation of polygon VZYW. Should have done it the other way. Okay, so it means that it was rotated. Okay, so this is not the original. The other one was the original. All right, so we're going to say that it was rotated from, let's say, can I select stuff? Can I go like this? Select all these things? I guess so, if I can manage to do it right. So we're going to go like this, see if we can get all of them. There we go. Oh boy, it really doesn't want me to take that other line segment. I don't know why. Yep, doesn't want me to take it. I'll have to move it over separately. Okay, so there's that. And we'll say that it was a rotation of, oh boy, this is going to be problematic, of this. So I'm just going to try and freehand this, guys. Sorry. Boom. 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 Okay. And that last line is not very good. Let's try that again. How about this? That's better. You get the idea. Okay, now, and it says VZYW, which means that V has to correspond to P. So that means that this is V. Z has to correspond to Q. Do you guys see what I'm doing? VZ. So it doesn't look like a 2. VZYW. Y. Oops. Y. And then W. Okay. So there we go. The other set of tools is so much better than this. I don't know why they do this. But anyway, okay. So VZYW. So basically I took that. Oh no, I screwed it up. Because look, it says it's a rotation. I did a reflection. Oh boy. Sorry guys. Let's try that again. Okay. Okay, sorry. V is P. Z Y W. Okay, there we go. Okay, now we can see that if I took this and rotated it around, it would land and look like that one, assuming that I could draw. Okay, so here we go. Is QRS congruent to, is angle QRS congruent to angle ZYW? QRS and ZYW, are those the same angle? Well, are they corresponding angles? If I rotate ZYW around and get it to land over here, would it be angle QRS? It looks like it would, because this is that slightly obtuse angle on the inside of the check, right? The inside of the check mark, if this was like a big check mark, not like a really square looking Nike symbol, right? ZYW would be the same as QRS. So yeah, those would. Here's another tip. Notice where QRS is. Last three letters. Notice where ZYW is. Last three letters. They're going to match. Okay? All right. So the answer is, well, it is. Okay? You can, right? It is. So it is congruent to that one. So this is kind of a trick question. Okay. 17. Suppose quadrilateral PQRS was both a rotation of quadrilateral VZYW and also a reflection of quadrilateral VZYW. Okay, so would it matter? In other words, if I rotated it and reflected it, would QRS still match ZYW? Well, yeah, because it's still in the same position. They're still corresponding angles. Okay? So here we can say that the two quadrilaterals have to be congruent. Well, how do they have to be? How do I know that they have to be congruent? Well, because aside from my terrible artwork here, if we do rigid transformations, because we're doing a rotation, that's a rigid transformation. We didn't change the shape. We didn't change the size. And we did a reflection. We didn't change the shape, and we didn't change the size. So as a result, they have to still be the same. Okay? So these two shapes, these two quadrilaterals, have to be congruent still. Okay? And the reason is that all we did was use rigid transformations to get from one to the other. Okay? All right, that's it.